we're going to learn how to use a calculator to calculate R. And you're probably going to want to use, on the homework, you're probably going to want to use some sort of technology because the data sets are going to be larger than the ones that we were using, and the numbers are going to be bigger, and you might have decimal numbers, so the data is going to be more messy. And it's easy to make little mistakes in your sums, and even though you're doing the whole procedure right, you still don't get the answer right. So you're going to want to probably use technology. So I'm going to show you on this particular calculator, the Casio FX300MS, and this is the one I recommended for the class. So I'm going to show you on this, and then if you have a TI-30 or a TI-84, you can probably find videos on YouTube that would show you how to use those. I might even look, and maybe I'll embed those along with this video on the Canvas page. So let's go ahead and do this. So we're going to find these sums using our calculator. So the way that you use this one is you want to first make sure everything is clear. So I hit Shift and the mode button, and this is what clears it. So I'm going to hit 3 to clear everything and hit return. When you see the lines across, that means you've cleared everything. Now I'm going to hit mode, and now instead of 2, I'm going to hit 3, and that stands for regression. So correlation and regression go together. And then I'm going to hit 1 for linear regression. So because there's other types of regression, like logarithmic regression, exponential regression, and there's more advanced types of regression, and we're just doing the linear regression. So I'm going to hit 1. And so now what I'm going to do is I'm going to put this data in here, and I'm going to put it in there as ordered pairs. So I'm going to put 4 and then a comma and 3.78. So just a comma in between the two numbers, and then I hit M plus, and it'll say N equals 1. So then 12 comma, so the comma is right there next to M plus, 3.05 M plus, 20 comma 3.19 M plus, 28 comma 2.56 M plus, 41 comma 2.09 M plus. Okay, so now the data is in there. So if I hit Shift 1, I get this screen. And so to get the sum of x, I'm going to press 2 and hit equals. And then there's the sum of x. In this case, it is 105. So I'll write 105. Oops. 105. Now, what about the sum of y? Let's hit, we'll hit Shift 1. I don't see the sum of y there, but if you look on this end, there's an arrow, so I'm going to press the pad over, and then the sum of y is 2. Hit equals, and that's 14.67. Okay. Now I'm going to hit Shift 1 again. So remember, this is the same that you did when you were calculating the standard deviation. Shift, and up above the 1 is S sum, so Shift 1. And then I'm going to hit 1 for the sum of x squared, so 3025. And then Shift 1 and go over, and then there's my y squared, hit 1 and hit equals. And then I'm going to use all those decimal places, 44.6887. And then that the sum of x times y, Shift 1, and then I go over, and then that's number 3 over here. And return, and I get 272.89. Okay. Now, n is just the number of ordered pairs, so n is 5. And so, very good. So I got the sums. So now what I need to do is I need to calculate the three SS's. Okay, so first is SSX, and so this is the sum of x squared, so 3025, minus the sum of x, 105, that quantity squared, divided by 5. So 3025 minus 105 squared divided by 5. And I get 820. So there's my SSX. So now SSY. This is going to be the sum of y squared, so 44.6887. Minus the sum of y is 14.67, that quantity squared, divided by 5. So 44.6887 minus 14.67 squared divided by 5. And I get 1.64692. I'm going to keep all those decimal places since it terminated. I don't have to round. And then SSXY. If you do have to round these, I would round to at least 4 decimal places is what I would do. But in this case, I'm going to keep all the decimal places since there's only 5. And then SSXY is the sum of x times y, so that's this 272.89, minus the sum of x, 105, times the sum of y, 14.67, all that divided by 5. So 272.89 minus 105 times 14.67 divided by 5. And I get a negative 35.18. So notice both the SSX and SSY are positive, as they should be. This is negative, and the reason for that is because it's a negative correlation. So looks like we're on the right track here. So now R is going to be the sum of x times y on top, divided by the square root of x, 820, times y, 1.64692. Maybe something like that. So negative 35.18 divided by, and in the square root I have 820 times 1.64692 in parentheses. So everything here is in parentheses on bottom underneath the radical. And I get, and then I'm going to round this to 3 decimal places, negative 0.957. And so indeed, this has a very strong negative correlation. Okay, they do line up along some line with a negative slope. If you have a different calculator, you want to check out on YouTube how to use that, but that's going to help a lot on the homework. You'll probably want to take advantage of that. And I'll maybe try to find some videos for the TI-30 and the TI-84 graphing calculator. So in the next video, what we're going to do here is decide whether or not the strength of correlation is, whether or not that's strong enough to to conclude that there's a correlation in the entire population. Okay, so the idea here is that this data is a sample of just 5 college students, right? Does that correlation in this particular sample give you enough evidence to conclude that there's a correlation in the entire population? So we're going to look at that hypothesis test in the next video. So